Test, test, test. Okay, perfect. Okay, so let's get right into it. So review. So we're going to start off very, very basic. And I know that's kind of rough for you if you've been keeping up, but I just want to make sure that I didn't lose anybody with any little thing along the way. So let's open up REPL. So the very first thing we started off with was just our hello world. So we did print hello world. Now within that, just that little line of code, there's some interesting things. So at this point, you should know functions, but this is a function. We've dealt with functions a few different times. Make sure it's recording. Okay, perfect. So you've dealt with functions a few different times. This function in particular is print stuff to the screen. And then here we're printing a string. And then you can see the output hello world. Now don't forget, unlike languages like Java and C and C++, single and double quotes are interchangeable. So I can print hello with single quotes or double quotes, and it's kind of it's the same thing. Both represent a string. It's a little bit trickier in other languages because most other languages that are C-based, single quotes denote, bless you, a special type called char, so a single individual character. But bless you again. But that's not the case in Python. So you can use single or double quotes. Then we had this idea of the variables, and so I can say x is equal to 10. Now notice that in other languages we would have had to declare the type ahead of time. So we might have had to write int x and then x equals 10 or int x equals 10. Either one would work. But in Python, we just set x is equal to 10, and then right away it knows that the first thing that we assign to x is an integer. So it's just an int now. Now there's a special function that if we want to get the data type of any variable, there's a special function called type. And then let's say, for example, I wanted to actually see the type of x. I could go and run it. But that's not, I'm just going to comment extra stuff as I go. So we don't really do that anymore. It called the function, but now to see the actual type of x, I want to surround that with a print. So you can see that the type is an int. Now notice here that we put a function inside of a function. So the way that worked is just like in algebra. It would have executed this function on the inside. It would have returned int, and then we print whatever it returned. Now, there are times where we want to have strings and variables together. So what I mean is that's just going to say the value of x is x. Now, what if I wanted to actually get the value of x? There's a few different ways to do it. There's actually 3 that I think are pretty common. There's concatenation. There are, I don't even know what it's called. It's where you use the % sign. But pretty much almost across the board, I've switched to these f strings. I really like these because they're much, much more condensed. Just as a kind of an aside, I'll show you the old way we used to have to do it. And then we'd have to comma separate the list. To me, this is considerably less readable than f strings. I like f strings because it's like you just put it in line. You just put an F in front of the string. And then anything that we put between curly braces, it's going to assume is Python code and not a string. So I can say that the value of x is, and because this is an F string, I just put it in curly braces. I run it. It says the value of x is 10. Yeah.
Could you show the other method again, real quick?
Yeah.
I just want to see it so I know what it looks like.
And then you know how in C-based languages we'll have like I don't know what they're called, but like if we use like printf, we'll have these character formatting codes like that. So this is for a digit. And then what we have to do is the weirdest syntax. Then we put this %, and then we pass it a tuple, and then bless you. And then so let's say for example here we only have, I'm going to comment out this just for 1 second. So we're going to say the value of x is, for anybody else who's confused by this, don't worry about it. He was just curious. So, but then let's say, for example, we had another variable. And then we just comma separate the list out from there. Enough arguments. X and Y. Whatever. You get the idea. You can see I messed it up because I don't use it very often anymore. It is strange though. It should have. I think there might need to be a comma in there somewhere. I don't know. But I don't use this much anymore. That's why I messed it up. So we'll just stick with one variable.
That actually worked for me when I tried it.
Oh, it did work?
Yeah.
I wonder if something just happened with the compiler. There we go. That's weird. Okay. And the final method, what you can actually do is what's called string concatenation. And so we can't just put x because it's going to complain because we're trying to put a string and a number together. So it's going to complain. So what we have to do is, yeah, there's something wrong with REPL today. Whatever. Either way, it would have complained either way, because you can't mix a string, you can't, whatever. But what you have to do is convert it into a string. So you have to get the string representation of a number. So you get the idea. But we'll, for your exam, all you really need to know is the F string. Now, what you'll notice is that, first of all, we don't have to, this is not a semicolon delimited language, so we don't put semicolons at the end of each line. I'm curious if it would actually run, if it would recognize it and just strip it out. Yeah, that's weird. It does, okay. But yeah, we just don't, we don't put semicolons. Now that does cause problems is because in a semicolon language, we can read multiple lines, and we know that the line of code is not done until it reaches the semicolon. But let's say, for example, I have a very long string. I can't do this in Python. In most other languages, it would have kept on reading code until it hits the semicolon. But because we don't have that in Python, each line of code is like a line of code. It's very important. You probably already know at this point that we could also use it for some basic arithmetic. So if we said, so we could do that. Now, a very quick question, should be kind of obvious. Remember we talked about the order of operations? It's the same as algebra. So what's the first thing that would happen in this case? Would we get 5 plus 2 or 2 times 3? Which one would be first? 2 times 3. So that just plain old follows the order of operations from algebra. If we wanted to not do that, we would just put parentheses around it. Okay. Now, we haven't taken an input in a really long time, actually. To be perfectly honest, I don't write a whole lot of interactive programs like that. It's almost always programs that I write that either take in command line arguments or on the web. It's very rare, but just to briefly go over it, if you want to make an interactive program, we use this function called input. And what that does is that returns whatever they entered in. So I can type in number. I'm just going to come at some of this extra stuff that's just kind of in the way. So it's going to ask for a number. I entered a number. Now, just out of curiosity, let's see what. So we already did this before, remember? So to get the type, there's a function called type. We pass it a number. But by itself, that's not useful. We have to actually print that out if we actually want to see the type. And I'm going to get rid of that too. Let's try this again. One more time. Okay, there we go. Now you'll notice that when I enter in things using this input function, even though I entered in a number 5, it thinks everything is a string. So what I have to do is I have to now say, okay, that number is no longer going to be a string. It's going to be an int. So I can do like int number, or the alternative way is to just do it at the time when we're getting the input. To me, this almost looks like it's trying to cram too many things in at once, but you could have done this as well. But here we can do this. Now, one of the interesting things with Python is that variables are more like a label than anything. So what I mean is that, let's say, for example, sometimes it's hard to come up with analogies that aren't more confusing. What happens is that this isn't like super strongly statically typed. So what happens is that number is just like a label pointing to somebody or to something. If you've seen pointers before, you can almost think of it like that. Like it's pointing to something. It's a label for something. But if I reassign number, so right now number is a string, I can say that number is equal to int number. And what happens is, this is very important. It evaluates the stuff on the right-hand side of the equal sign. It gives us back a number. So let's say I entered in 5. And then now number, the variable number, is going to equal to 5, which is an integer. You can't typically do this in languages like C. I can't start off as an int and then change it to a string with the same variable. Once it's been declared, it's been declared. Python's a little bit different. Now, let's talk about if statements very briefly. So what I can do is the way it works is I have if some condition. Most of the time we're just going to be dealing with greater than, less than, or equal. There's other variants like greater than or equal, less than or equal and stuff, but let's just talk about those 3 right now. Greater than, less than, equal. If I want to check to see for equality, I use the double equal signs. I use the 2 equal signs. So if I wanted to say if x is equal to 5, I would do that. So if I enter in the number 5, hold on, so REPL's acting kind of funny here. Let's make sure. Oh, sorry. So not x equals 5. we input a number. So we say number is equal to 5. Try this again. Now the way if statements work, and this is a very common source of confusion in Python, is that rather than curly braces, so if you've taken like a COP2030 type class, you're probably used to these curly braces. So rather than these, we use the space character, either space or tab, depending on, you know, it's kind of a code style thing. And what you'll notice is that rather than surrounding it in parentheses and using curly braces, what we do is we say if, then we spell out the condition. We want to say if the number is equal to 5. Then we use a colon, and then we indent. So this is considered a code block. Now you have to be very, very careful about this, because so let's say, for example, I enter in 5 again. So this code right here is all part of the if statement. And you'll notice that REPL, the editor, is giving us a little bit of a visual cue. You notice this line right here. But as soon as we unindent one level, we're back to the main line of execution. So all this code right here, this is all part of the if statement. So these are the actual statements that execute. These statements right here execute inside the if statement. But as soon as we are unindented, we're just back to the normal code execution. So say, for example, if I entered in 7 instead. So this is always outside of the code block. Now, one thing to also note that throws off a lot of people is this double equal signs. Remember that 2 equal signs stands for equality. 1 equal sign stands for assignment. So back over here on line number 9, I was taking this expression, 5 plus 2 times 3, getting the result, and then storing it in X. Here, what I'm doing is I'm taking the number that they entered, checking it against another number, and seeing if the 2 are equal. So assignment versus equality. Assignment is storing something somewhere. Equality is checking to see if the thing on the left is equal to the thing on the right. Now, what would have happened if I hadn't converted this into an integer? Say, for example, I hadn't written this code, and I said number is equal to input, and then I said if number is equal to 5. And then I entered in 5. Is this going to match? Yes or no? No, it didn't match, because I'm trying to compare the integer 5 with the string 5. Notice the difference? So here I've got the number 5. Well, if I want to actually check to see if it's against the string 5, I can do that. So now I'm checking the string 5 against, or we don't really need the type. We already know what the type's going to be. Convert it to an int. And then now here I'm comparing the integer 5, I'm sorry, the integer number 5 with the int 5. Yeah, question?
Could it work with a float as well?
So floats are a little bit tricky. I went through an example a long time ago. Let's talk about that. The tough thing with that is I'd have to dig through the examples. I can't remember the exact numbers. Doubles and floats aren't exact. So I may think I'm comparing it to, like, say, pi. I think I'm comparing it to 3.14, but what I'm actually doing is comparing it to like 3.14000000000001. So floats and doubles aren't exact representations. So just as a general rule, I wouldn't ever use the equality with doubles. Usually what you do there is some sort of comparison. So let's take a step back here again. Okay, so what if we did this? Instead of the double equals, we said if number is greater than 5. Okay, let's go ahead and run this. And I enter in 7. Well, 7 is greater than 5. Perfect. But what if I hadn't converted it to an int and I wanted to compare strings? This gets a little bit tricky because it's now we're comparing the string 5 and the string 7, which is like a little bit less clear. So what I would do is be careful about, because then it wants to compare it, I think, alphabetically. Because, okay, 7 matched, but would 17 match? Well, 17 is greater than 5. That's confusing. Well, if you sorted it alphabetically, you'd see that 17 would be before. So be very careful about things like that, about doing comparisons with strings, because you have to remember, once you start with strings, you're going to be comparing alphabetically. So it's just easier just to stick with numeric comparisons. I'm comparing the number 17 with the number 5. Now we have if statements, and then we have ifs, else ifs, and so on. So I can have an else, and this is in all other cases. So let's say 2, that doesn't match. But the same thing still applies. I've indented one level. When I have my else, it's going to be aligned here. And then I indent one code block. But then when I'm done with my ifs and elses and all that, then I just go back to, I unindent. De-indent, I don't know what the correct word would be. But hopefully you see that what's going on here. Okay, any questions about if statements? Let's, this REPL is getting a little bit busy. Let's go ahead and I'm going to start another REPL here. Don't forget we have if, and then we also had else, but then we also had if, elif, or we can have if, elif, else, or if, elif, 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 else. So we have a bunch of different ways that this can be used. Now let's go back to our car rental example, because I think that's a pretty good illustration. We'd have somebody enter in an age, so we said age is equal to input, enter age, enter in their age. Let's just deal with integers, so we'll say age is equal to the integer representation of their age. And then we would say if, so let's write it the incorrect way first. So the logic was that if the age is greater than 18, can rent car with the fee. Elif, this is similar, you can think of this as else if, but it's written as elif. Age is greater than 25, print can rent car without the fee, and in all other cases cannot rent car. So we have them enter in their age. And let's say they enter in 19. Great, they can rent the car with the fee. But the problem is that this logic isn't correct. So just make sure that you keep track of the logic. So if I enter in 27, it's going to say, that's weird. Why did it say that? It's because this is the first thing that it matched. So we have to switch around the logic. And the first thing that we want to test for is that the age is greater than 25. And then elif, age is greater than 18. And now let's test the age of 27. Perfect. test it with the age of 19. Great. Now, the thing that a lot of people get confused with is this idea of if statements versus an if, elif, else. Remember that when we have else ifs, they're chained together. So what I mean is, as soon as I entered in 27, this matched. It ran this line of code, and then it jumped to the end of the program. It jumped all the way down here to line 12. If we had changed that to if statements, and I enter in the age of 27, it prints both. Why does it do that? It's because it matches here. Okay, 27 is greater than 25, prints this. Then it goes here. Because they're not chained together, it keeps on checking things. So now, obviously, 27 is greater than 18. So that's why we end up with the situation where it printed both. But we don't want to do that. We want to say if this condition, else if this condition, else. And that way, as soon as the first thing it matches, it stops. So this is a little bit fragile because we're dependent on the order. Now remember we talked about ands. I can check for two conditions at the same time. So to make this a little bit more resilient to where the ordering actually doesn't matter, what we can do is we can say that, okay, if the age is, let's do this right here, the LF. If the age is greater than 18 and age is less than or equal, actually I don't like this logic. So I think we said originally 25 and greater. So let's change this to let's change these to greater than or equal to, greater than or equal to. So if the age is 25 and older, age is 18 and older. And so here we're going to say if the age is less than 25. So essentially we're saying between, we're giving an age range. So remember how this and works. I'm saying if the age is greater than or equal to 18 and the age is less than 25. So essentially it's between, I sort of bounded it. So don't forget how this and works is that we're checking for two things at the same time. There's four possible outcomes of this. None match, both match, the first thing matches, the second thing matches. Out of those four, the only time this executes is when both things are true. So let's say, for example, the age is 20. Well, obviously, 20 is greater than 18, and 20 is less than 25. Perfect. If I entered in the age of 17, well, in that case, neither matches. Or I'm sorry, this matches. So 17 is less than 25, but 17 is not greater than 18, so it would match. So with ands, the only time it proceeds is when all four things, I'm sorry, out of the four possibilities is when both things are true. That's probably overly complicated. You can read it very easily in English, you know, and just say, okay, if the age is greater than 18 and the age is less than 25, proceed. The one thing that you have to be careful with is that a lot of times we don't say these in English the same way. I might say if age is greater than 18 and less than 25, but that's not how we write software. We have to be very specific. We have to write if the age is greater or equal to 18 and age is less than 25. So you have to be careful about that because I've seen a lot of people do things like this on assignments before, and that's incorrect. That's how we say it in English, but that's not how we code it. So let's briefly talk about functions, and I think functions are probably a good stopping point for today. And the next class we'll start up with like dictionaries and other data structures like that. Okay. Don't forget we can create like these menu systems. We did an assignment like that, but I think we're good on if statements. I want to dive right into functions. So let's do one more here for functions. So we've already used functions. type, print, input. And the basic idea of a function is I have a clearly defined input, some magic happens inside of the function, and it spits out an output. Now, to me, the easiest example, it's kind of like very made up and manufactured, but if I want to add two numbers together, I have this box, and I feed in two numbers, and at the other end, it's going to give me a result. So let's say, for example, I made a function called add two numbers, and it takes in a couple of numbers. We'll just say a and b. We can be very generic. So that the result is a plus b, and we return the result. So the way we create a function is that we write this keyword def. We give our function some sort of useful name. Follows the same naming conventions as variables, that we use letters, numbers, underscores, can't start with a number. We have inputs. In this case, we're saying A and B. We take in A and B, we add them together, and then we have a result. Now, to spit out something the other side of this box, we have to use the special keyword return. So we want to take in two numbers, and out the other side of the box, give back the result, and that's what return does. Now I can run this, but nothing has actually happened. So this right here is the blueprint for the function. One quick note, notice that just like with if statements, with functions we have code blocks. So as soon as I use this colon, I have a code block. Remember that with if statements, we had our normally we have our curly braces in C-like languages. Same thing with functions, is that normally we have curly braces. With Python, we have this idea of using the colon and then indentation. Now when I'm done with the function or the function definition, I just unindent one level. I don't like the default on this. I like to have 4, but I think I have to like do that and reload or something, right? It's not really worth the time. But 4 is typically the standard in Python. So this defines the function, but then to actually use it, I'd have to call the function. So add two numbers. Notice my indentation level. I'm all the way over left. This code is not inside of the function. So if I wanted to add 5 and 2. So this actually executed the function and returned a result, but that's not terribly useful for us. So let's say, for example, I want to store the result in x. Print x. Now, we can put basically any code inside of these functions. We can put if statements and for loops and all these other things like lists and so forth. And when we call this return keyword, it returns the thing back on the other side. Now, once we've done that, we can't go any further. So if I were to try to do something like this, this is never going to run, because as soon as we hit return, the function stops. Okay, so notice that it never prints hello. It's because as soon as I return results, the function doesn't keep on going. Now, usually, for good function design, we want to avoid inputs and outputs inside of the function. So I could take in the numbers over here, like down at the bottom of the code, and ask for the two numbers, and then print down there, but you don't want to do it here inside of the function. The function, you want to clearly define input and then return an output. The reason being is because you never know how somebody's going to use the function. Say, for example, I wrote some sort of linear algebra software package. It'd be kind of a useless library of functions if the only way it could be used is like putting input and output. So let's say, for example, in a video game, I'm using a lot of linear algebra, which is pretty common. within my own program, I want to be able to get the result of that. I don't need it to display to the user. Most likely what's going to happen is I'm going to take that result and use it in some way in like a physics engine or something like that. So directly displaying results to users inside of functions and getting input from users inside of functions tends to generally not be a good idea. That being said, there is one exception. When the whole purpose of the function is to get input or output, then it's okay. So I might be able to do a function like we've done before. We had print menu, and we had a menu-based system. We could say like 1 for miles to kilometers, and so on. And then what I could do is anytime I wanted to print that menu, I could just call the print menu function. And that's nice because in reality, this menu would probably be very large and complex, and then it gets rid of duplicate code. So normally we want to have, we want to avoid I/O, inputs and outputs, inside of the middle of our function. We want to very clearly define input, very clearly define output, except for in the cases where we can just kind of relegate everything, all of our I/O, to a specific function. And the reason for that is, I think I gave this example in this class, is that imagine if I'm writing banking software, accounting software in the 1970s, and I mix my I/O and banking logic. Then all of a sudden in the 70s we have like green screen software. In the 90s we get like Windows 95, and I want to rewrite that software to be able to use like a graphical user interface. Because I've mixed my inputs and my business logic, that causes problems. I just can't simply reuse the business, even though banking between the 70s and 90s probably didn't change that much, the basics of it anyway. I have to rewrite the program or parts of the program. And then all of a sudden 10 years later we've got the web, and I've got to rewrite it for the web. And then all of a sudden I've got it for mobile devices, I have to rewrite it for that. So we want to separate our logic from our inputs and outputs, because the inputs and outputs that we use may change. I may decide to get inputs from a text file or a network stream or a million different ways, but adding 2 numbers, that doesn't really change. Running a bank, if somebody deposits money and I increment the total, that doesn't change, whether I get the input from an ATM machine or a website. Okay. And then let's just briefly talk about for loops just for a second. So we don't have for loops like we would in C, where we have for loop like this, int I is equal to 0, I is less than 5, I plus plus. We don't have anything like that. What we do is we have a for loop, and the way it works is we have for and then some variable in, and then we have this thing called a generator or some sort of iterable. So in this case I can call a function called range, and what that'll do is that'll give me the range. So that'll give me back 0, 1, 2, 3, 4. And then what I want to do is each time through the loop, I want to print that number. Okay. By itself, this can be useful if I want to do something a certain number of times, but many times we use this with a list. And so I guess that's what we'll start next time, is that we'll start reviewing lists and dictionaries and other data structures like that, and then we'll talk about classes, and I think that'll pretty much take us to the exam. Okay. So this is a good stopping point, because I know some people might need some last minute help on a few things. So any questions on what we went over just today? Okay, any questions about the rules of the midterm? Everyone's still, or I keep on saying midterm. Rules of the final, which follow the midterm exactly. Everyone's good with that? Cool. Okay. Well, if there's no questions, I'll see everybody on Wednesday. So you can head out if you're caught up on everything and you don't have any questions. But for anybody else who, like, for example, like wants to take up this offer about the makeup assignment, which is due today, stick around and I'll give individual help on things. Okay, so we'll break a little bit early, I realize the majority of people are all caught up and just can leave, so you can head out. But anybody who needs any additional help, stick around, and we'll use these last 20 minutes of class for that, okay? Okay, stick in there for the last few classes. I know this is tough, especially after Thanksgiving, but just hang in there, and I think everybody okay. Okay, see everybody on Wednesday.